Section 8.3 and 8.4, basically we're moving on from chapter 7 and we're going to go ahead and start skipping into chapter 8 and hitting some of the big, really important stuff. And what we're going to actually do is we're going to be graphing quadratic functions. So we actually know a good portion of how to graph a quadratic function already because we spent a lot of time on factoring. That is a huge skill to help you graph. But let's just go step by step. First off, a quadratic function is generally written like this: y equals ax squared plus bx plus c. This is our standard form, and I've mentioned this in previous videos. And our job in graphing it is to find the following. First off, I need to find what's called the axis of symmetry. So if I were to graph this, it might look something like this, and it makes a parabola, and I have this particular shape. The axis of symmetry is the line, that vertical line that literally divides the parabola in half, and it basically creates a mirror. Whatever is on this side is mirrored to the other side. That's what it is. And the way we find the axis of symmetry is by using this equation, which is very important. We're going to be using that a lot in this video. X is equal to negative b divided by 2a. If we can get the axis of symmetry, which is this right here, it allows us to get what's called the vertex, which is basically either the top or the bottom of the parabola. So in this particular case, my vertex would be right here. This would be my vertex. And how do I get this value? It's basically I plug the axis of symmetry value back into our original equation. So I would have an x value and a y value for that vertex. All right. The next thing is what we would call the Y-intercept, which you already know is basically where the line crosses the y-axis. So this right here would be my Y-intercept. And the easiest way to identify this is basically looking at the c in the equation. So this last term of c right here is what we call a constant. It represents my Y-intercept. And it's very much reminiscent of what you know in this particular equation, y equals mx plus b. That last term is a constant, so this, like c in this one, happens to be your y-intercept. All right, x-intercept. That's basically these points right here. So this would be my x-intercept, and this would be my x-intercept, okay? And this is where the parabola crosses the x-axis. Here's a little hint though. Sometimes you might have, like in this case, we have two x-intercepts. Sometimes we might have one, and the way that would look is if I drew my graph, my parabola might look something like this, and it just touches the x-axis, and so it only gives me one. Or I could have no x-intercept at all. And so here's my graph, and this time my parabola may look like this. It never even gets to the x-intercept. Or it could look something like this, and it never gets to the x-intercept. So that's something that you might want to keep in your back of your mind, is that you can either have one, two, or even no x-intercepts at all. How do we find these x-intercepts? Well, one way is by factoring, which is what we've been doing over the past several videos. And the other way is what we call the quadratic formula. I will go ahead and tell you this is probably going to be your best friend over the next couple of days, because if you utilize this, it's going to save you a lot of time and you don't have to worry about factoring. Both of these methods are valid, but this method right here is usually the most quickest way and most surefire way of not making a mistake if you follow all the procedures correctly. So let's go ahead and sing a new song for you. X is equal to negative b plus or minus square root plus or minus square root b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. Let's do that one again. It's x is equal to negative b plus or minus square root b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. And by using this formula, we are able to calculate where the x-intercepts are, and sometimes whether it be 2, 1, or even none, okay? And that right there is an interesting question. So we probably won't see anything in graphing where there, but an example that I'm going to give you when it comes to none, but we'll show you later. After you identify these major 4 things, the next thing is just identifying a couple other things. First off, extra points. So I'll show you what I mean in just a minute. Just by looking at this graph, I've been able to tell you the Y-intercept, the vertex, and the X-intercepts, but just these 4 points is not enough to make a proper graph. I need to know some extra points, and I'll show you how to do that in just a second. The next thing that we need to know is whether it opens up or down. So after I graph it, I can tell that this opens up. But I also know another way as well is by looking at the A value. The A value denotes this. So if it's a positive A, it opens up. If it's a negative A, it opens down. All right, so this is something for us to know. Then lastly is the last 2 things are, first off, the minimum and maximum value. That's pretty easy. Basically, it's where the vertex is. So in this particular one, it has a minimum value of this point, but there is no maximum because it continues to go all the way to infinity. While at the same time, if we look at this one has a maximum value, but it has no minimum value because it would continue on to infinity. Lastly happens to be with the domain and range. Remember and recall that domain happens to be your x values. So domain is really simple on a parabola. It is constantly going to the left and constantly going to the right. So the domain will always be all real, okay? While the range is a little bit more difficult, it's going to be based upon either your minimum or your maximum. And I'll show you what I mean by that in just a second. So this is all the basic concepts and definitions about how to graph a quadratic. Let's actually start doing it. All right, so I've given you about 4 different things. I'm going to actually do all of these with you just for practice. I'm going to do them all. And we're going to go down the line and we're going to define all of these things. Well, first off, I can't define domain and range right now, but I can define some of these other things. X-intercept, it's not easy to do. Y-intercept, I can define that pretty easy by looking at the last value. So my Y-intercept right now is 0, 2. That's pretty easy because that is a constant. My vertex, I cannot do anything. Minimum and axis of symmetry currently cannot do anything. However, I can look at whether it opens up or down by looking at the first term. Since this is a positive term, it means that this will open up. So this is all I can do just by looking at this equation. So the next piece that we want to do is let's go ahead and start working our way and trying to find some things. I like always starting with the axis of symmetry first. That's like the first thing that I like to look for. The axis of symmetry, the way we do that is using that equation that I gave you, x is equal to negative b over 2a. And what I'm going to do is I'm going to plug these terms into my equation here. So I have x is equal to a negative 9 divided by 2 times 3, okay? When I solve this out, I get x is equal to negative 9 divided by 6, and this gives me a little something kind of crazy, and I'm going to show you something in just a second. Negative 9 divided by 6 gives me negative 1.5, so that wasn't as crazy as I thought. So x is equal to negative 1.5. This is my axis of symmetry. So I can write that down. X is equal to negative 1.5. And notice how I wrote this as an equation. I didn't just write negative 1.5, I wrote the equation. Well, now I can look at something that's called the vertex. All right, that's the next thing that I can do. The vertex, I've told you that basically all you have to do is plug this x value back into your original equation. So I can say this, y is equal to 3 times negative 1.5 squared plus 9 times negative 1.5 plus 2. All right, and that's going to give me a y value. I can work this out by hand, but why work so hard? I'm going to show you a new trick with your calculator. I've got negative 1.5 in my calculator right now. There is a button that says STO in this little arrow. This means store. I like to say it's my stow button. So I'm going to take this and I'm going to stow negative 1.5 away, and I'm going to stow it into my x value. So every time I type x, it's going to give me negative 1.5 in return. So I can actually say 3 times x, and it would give me negative 4.5. So as you could probably already guess, what I'm about to do is I'm going to plug this equation in now, because I'm going to say 3x squared plus 9x plus 2. Because I've got that negative 1.5 stowed away, I can hit enter, and it gives me a value of that my vertex, or my y value, is negative 4.75. That means that my vertex can be found at negative 1.5 and negative 4.75. That is my vertex. So I can write that down. Negative 1.5 and negative 4.75. That is my vertex. Now, here's the thing. This is also the nice part. Because I know that this opens up, my graph will probably look very similar to something like this. I don't know if this is exact, but it does tell me that my vertex is here, and that that particular point is going to be my minimum value. So my minimum value is actually going to be negative 4.75. That's as low as I'm going to get, all right? Because that's my vertex. And since I knew it was opening up, that's my minimum value. Now my job is to find my x-intercept, okay? So let's do that. This time what I'm going to do is I'm going to use my quadratic formula. So I'm looking for the x-intercepts, and I don't know how many there will be, but we're going to find out. So I'm going to write my equation. Negative b plus or minus square root plus or minus square root b squared minus 4ac all over 2a. And there's my equation. Now that I have that, it's just a matter of plugging in my variables that I had, not my variables, but my coefficients that I have right here. So I'm going to say x is equal to negative 3, oops, sorry, wrong one, negative 9 plus or minus the square root of 9 squared minus 4 times 3 times 2. All of this is going to be over 2 times 3. Now my job is just to basically start to simplify this. X is equal to negative 9 plus or minus the square root of 81, because 9 squared is 81. 4 times 3 is 12, times 2 is 24, so minus 24, all over 6. Let's continue to work this out. X is equal to negative 9 plus or minus the square root of, let's find out what 81 minus 24 is, gives me 57. All right. And I get that this is all over 6. Okay? Now, we have an issue. We've got to figure out all this out. So we can break this apart and say negative 9 plus the square root of 57 over 6. We can do that. Or we could say x is equal to negative 9 minus the square root of 57 over 6. Okay? So why did I do that? Because of this symbol, the plus or minus symbol. It breaks it up into two equations. Now that I've done that, it's just a matter of plugging things in. Negative 9 plus the square root of 57. Hit enter. I'm going to divide by 6, and I get that my answer for x is going to be, let's round to the nearest tenth, is going to be negative 0. I'll round to the nearest hundredth, 25, give or take. That gives us a little bit of an example, okay? And then I could do the same thing on the other side. Negative 9 minus the square root of 57, divide by 6, and I get, I'm going to round this one again, I'm going to get that x is equal to about negative 2.75, somewhere around there, okay? Now that we have our x values, we can kind of put that down, and we can say that our x-intercepts were at negative 0.25 and 0. That's one x-intercept, and my other x-intercept would happen to be at negative 2.75 and 0. So those are those points. All right. Now, with all this, it's just a matter of kind of plugging it into a graph, all right? So I'm going to kind of sketch a small graph up here. And we're going to do the best that we can with the numbers that we have. So let's do something that looks like this. All right, and I'm going to count by ones. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And I'm going to plot what I know. So my x-intercepts happen to be at negative 0.25, which is probably right about here to the best of my ability. Sorry about that. I'll bring it down. And then my next one would be at negative 2.75, which would be right about here. So those are my x-intercepts. My y-intercept happens to be at 0 and 2, so that would be here. Okay, my vertex is at negative 1.5, so negative 1.5 and negative 1, 2, 3, 4, about 0.7, so right about here. Okay, that would be my vertex, and that's also my minimum value. Now, I've gotten 3 points here, or 4 points, I should say. But here's the thing, this is probably not enough. And so this is where your axis of symmetry comes in, is I'm going to go ahead and put that in here, really light. Okay, this is my axis of symmetry. And whatever is on one side, I can mimic on the other side. So if I were to look at this, if I were to go over 1.5, it would be right about here. Okay, so I can mirror this over there. And by doing so, let's slide that in, I actually have got a point of reference that I can make my parabola. And because I hand-did the drawing, this is pretty, not too terribly bad, but this is basically it. All right, so I was able to find my extra point by the other side, had those points, connected them up, and I'm done. Now, the last thing happens to be domain. Remember what I said, because a parabola always goes left and right, it's basically going to be all real, okay? And my range, on the other hand, is going to be different. Notice that my smallest number, my minimum on this thing, is negative 4.75. So that's telling me that y, my range, will be greater than or equal to the negative 4.75. I will never get smaller than this number. All right? So let's try to do the next one a little bit faster this time. All right? So I'm going to go around and let's go ahead and do each individual thing. So I have my equation, y equals negative 2x squared minus 2x plus 3. Well, the first thing I can do right off the bat is I know that my y-intercept is going to be at 0 and 3. That's easy to know. And I also know that this is going to open down because it has a negative 2 for my a value. So this is going to open down, which tells me that my minimum value of this, we actually can't tell because we got to find the vertex. So let's go ahead and do that. The vertex, to find that, we're going to go x is equal to negative b divided by 2a. So let's plug things in. X is equal to negative 2 divided by 2 times negative 2. That gives me x is equal to a 2 divided by negative 2. Times 2 gives me a negative 4, so x is equal to a negative 1/2. So my axis of symmetry is x is equal to negative 1/2. Now that I know that, I can find my vertex by going and plugging this back into the equation. Y is equal to negative 2 times negative 1/2 squared minus 2 times negative 1/2 plus 3. And I'm going to use my stow button again. So let's clear this out. I'm going to go negative 1 divided by 2 gives me negative 1/2. I'm going to stow that as my x, and I'm going to plug that into the rest of it into my calculator. Negative 2x squared minus 2x plus 3. Hit enter, and I get that my y value, or my vertex, is going to be at 3.5, or to be more specifically, negative 1/2 and 3.5. That is where my vertex is. So negative 1/2 and 3.5. That means that my maximum value is actually going to be 3.5 because I'm not going to get any higher than 3.5 because this will be opening down. Now that I know all of this, it's just a matter of finding my x-intercept. And I can do this one of two ways, but I can either factor or I can use the quadratic equation. Let's use the quadratic equation. So we just found the vertex. Now we're going to find our x-intercepts. And I'm going to use that x is equal to negative b, plus or minus square root, b squared minus 4ac, b squared minus 4ac, all over 2a. So now that we have that, let's plug everything in. X is equal to a negative 2 plus or minus the square root of a negative 2 squared minus 4 times negative 2 plus times 3. All of that is going to be over a 2 times a negative 2. All right? So now let's go ahead and simplify all of this together by using Pemdas Rules. Negative 2 would give me x is equal to a positive 2. Plus or minus negative 2 squared gives me 4. Then I have negative 4 times a negative 2, which would give me a positive 8, times 3 gives me a 24. So that would give me plus 24, and all of that is being square rooted. So let's double check myself. I'm going to say negative 4 times negative 2 times 3. Yes, I am correct on that. Okay, cool. And all of that is going to be over negative 4. Let's continue working this out, and I get x is equal to 2 plus or minus a square root of 28 over negative 4. Now that I have that, I can break this up into two different distinct equations. X is equal to 2 plus the square root of 28 over negative 4, and x is equal to 2 minus the square root of 28 over a negative 4. Now that I've done that, it's just a matter of plugging things in the calculator. 2 plus the square root of 28 divide by a negative 4 gives me that my x-intercept here is approximately, we're going to say, negative 1.9. And we're just going to round a little bit. Actually, 1.8 is better. So it's about a negative 1.8. And this one, 2 minus the square root of 28 divide by a negative 4 gives me, this one would be about 0.8. Okay, cool. Now that we have that, it's just a matter of plugging things in. Okay, so we know our x-intercepts happen to be this, negative 1.8 and 0, that's one intercept, and my other intercept happens to be at 0.8 and 0, okay? Now that I have that done, I can take this information and make myself a very small graph again. And again, because I'm hand doing this, it's not going to be exact, but for our purposes, it will be fine. So I'm going to count by ones again. 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. Let's plot my intercepts. Negative 1.8 would probably be right about here. Negative 0.8 would be right about here. My y-intercept would be at 0 and 3, so that would be here. Then my vertex is at negative 1/2 and 3.5, which would be right about here. And then my maximum value is there. And my axis of symmetry, just to continue going on, would be right about here. All right. Now that I have that, I need to find my extra point. So I can do that by just mirroring this point directly across. So it would be approximately here when I mirror it. And if I don't like that, I can put another number in there. So let's say the answer is, let's put 1. Let's go ahead and put 1 in there, because right now this is like 0.8. Let's find out what happens if I put 1 in there. So I'm going to hit 1, stow as x, and then I get this. I'm going to put negative 2x squared minus 2x plus 3. And let's see what happens. I get a negative 1. So when I do that, it would be here, and its mirror counterpart would be here. Now that I have that, it's just a matter of sketching out my graph. And I am done. So what I'm actually going to get you to do now is I want you to try to find these others on your own. I want you to try to, oh, wait a minute. After I've done that, I can basically check out my domain and range. My domain, as always, is going to be all real. My range happens to be, my maximum value is that y is going to be less than or equal to 3.5, because that's as high as I'm going to go is at 3.5, and everything else is going to be less than. Now that we've done that, why don't you try to do 3 and 4 on your own and see how you do. All right, so I purposely messed with your heads on questions 3 and 4. If you notice the first two, that they actually had x-intercepts, whereas in these two, may not be the case. So when we go to solve all of this, everything worked really well until we got to the x-intercept. What you would have found is that there was only one x-intercept. All right, when you went to go do your quadratic formula, you would have found out that x was going to be equal to 4 no matter how you solved it. That means that there was only one x-intercept. And at the same time, that x-intercept was also your vertex and also the same number for your axis of symmetry. So the only thing that you had available to you at that point in time was just this one point. So your job was basically to find some extra points, and this is why I gave it to you, was to hurt your head. So what I did was I just kind of put some extra points to the side here. So when x was 1, I know that y was 9, and when x is 2, I knew y was 4, and then so forth, so on. And knowing these points, I'm actually able to mirror those exact same points across the way. All right, and when I do, I'm actually able to get my parabola that I want. Okay, so I had to find these points, and then I had to mirror the points on the other side of the graph. All right, number 4 was very similar, except you probably came across this, and I'm going to show it to you. So you started plugging in everything into your quadratic formula, and everything was looking great, and you had 12 plus or minus the square root of negative 32 divided by 4, and then more than likely you tried to break it up, and all of a sudden what ends up happening was you start plugging it in, 12 plus the square root of negative 32, and you hit enter, and it says non-real answer. And no matter how hard you try, you got this, and it's even possible you try to make it work. Well, why is this the case? Why is this a non-real answer? Well, let's look at this question again. It's asking for the square root of a negative 32. Remember, square root is saying what number multiplied by itself gives me that number. So I'm asking the calculator to tell me what number multiplied by itself gives me a negative 32. There is no known number in the universe that when multiplied by itself will give me a negative number. How do we know that? Well, basic rules. A positive times a positive equals a positive. A positive times a negative equals a negative. And then lastly, a negative times a negative equals a positive. I cannot take a number and multiply it by itself to get a negative number. I can only take a number and multiply it by itself to only get positive numbers. That's why there's no such thing as a negative number in a square as a square root. All right, that gets into something that's called imaginary numbers, which is something you'll learn much later. But anyway, as you can tell, it didn't work. It does not give us an answer. What does that mean? Because x was non-real, it meant that you do not have an x-intercept. There was no way you could do it. But with that being said, you could calculate everything else up. You should be able to find your y-intercept, your vertex, your minimum value, and your axis of symmetry. Knowing these things, I was able to plot that information, and I also picked 2 variables for x and plugged it in to see what it would give me. And I was able to get this. Knowing that, I can basically mirror my picture right across the way, and what would I get? It would be something right around like this, and here is my parabola. All right, so this has been an extra long video, longer than I expected it to be, but this is the main gist of it. And this is what you're going to be practicing for the next several days, is getting these types of equations and graphing them. All right, and I'll see you in the next video. Bye-bye.